Hello. Today I would like to talk about stack, mm, stack, queue, and single linked list. Yeah, I'll show you the implementation. The single linked list is like array, not an array, but you have to how you implement, how you insert it. It's like you make a node and then you use a pointer to put the next one right here. Um, Stack is um, last in, first out, and queue is first in, first out. How I would implement it implement well is to make this as a head and make this as a tail, and then try to delete these. Try to pop this node and then show the data inside here. And then I think that is what it is. So let's go to the coding right away. Um, how this will work is like first, how you compile is like, uh, this is CPP file. It should be this. Yeah. So debugger running all. LP thread, you don't need it, but I just include it. And I want to do multi-threaded programming. And this is how you compile. So I'll show you how I will write it. First, you include stdio as usual, and then include stdlib.header file. And then when you first try to make a single linked list. Okay, I'll start with the stack. You need to create a node, right? So type def struct node, something like this, and then node. How you can do it is struct node pointer. We need a next pointer. That's which gonna point to the next, the what element it will have, and then some kind of data it will have. For now, I will have int data, which is it's like a simple kind of data. So node will only have these two data. One with the data, and then pointer next, which points to somewhere like here or something. Right, and then after that, I'll create type def struct, I don't know, list. Then list. I'll probably need node pointer to reference this one, node pointer, which is to head, node pointer for tail, uh, and then int size for something like, if I need it in the future, then I'll make it later. For now, in order to create a list, you create something like list pointer, and then L1 equals initialize list. That's how I will make it. And then how I will make it is void initialize list. And then you would like to create malloc this amount, right? So list pointer list, and then this should be returning list as something like this, right? Then resp is malloc size of list. Then after that, the list head, I'll first put it as null. List tail as null and list size as 0. And then I'll return list. Return list. So this will make it, and then if I just for the make clean make there's no error yet. So and then what do we need now? First we need a insert, right? For if I think if this is as a stack, then what I could do is void insert head, and then I'll have int data, something like this. And then I need insert tail, right? Since I am only considering stack for now, I'll only do insert head. And then what do I need? I need pop, right? Int pop that returns no and then I need this, right? And then how I will do for stack is that I'll call this as stack for now, like as for the purpose for, looks much better, right? And then I'll put list pointer L like this, then list pointer L to make sure, I'm accessing the right data structure. So first insert head, and then what I would put is 10, and then S, something like this. And then I obviously should pop, right? But I should be able to print this, right? Print decimal. Something that looks like this. So how should I insert this? For starting, we gotta know if the size is equal to 0, then I'll know that if size is equal to 0, then I know the list is empty, right? Then I make something like this. And then I should return here. And if this is 0, then I let the L hat equal to new node malloc size of node. Then before putting here, I put node pointer here. And then I can declare this as new node data is equal to data, right? And then next equals to null for now, at least for now. I'll put this new node. Then what will I need? I'll need to increase the size, right? Size plus plus. And then I use the early return pattern so that it makes it more clean. And then after that, if this is not the case, then if this is not 0, then if it's 0, then it's gonna return here. If it's not 0, then this will not pass. And after that, how should I do it? If the previous one is there, then what should I do? The new node next should be equal to previous one, right? L of head, right? And then what should I do? L of head equals to new node. So I declare that I create this new node, and then there was a previous head, something like this. first I point this to here, and then I change this head to make it to this. Then I know that this head has been updated, right? So this is a two-step, right? Um, I guess and also I also need to increase this by 1. I also need to declare this. When I first instantiate it, I also have to do something like L tell equals to new node. I just only update the head for this case. And that should do. And because only this case will be null, uh, I'll put it here. And then I'll return here. And after that, I'll do pop. How would I do it? It's quite simple. L of top, no, head, right? Int data equals to of head of data. And I need to delete this, right? So temp, how should I do it? Only thing I should do is I'm gonna delete this part, right? So what I will do is I'll make a node pointer of dnode, calling dnode as a L pointing head. I update this L head to, where should I update L head to? I have to update this head value to here first, and then I'll delete this. So change this head to here. Then how should I do is L head equals to L head next. That should do it, right? And then L head. And then after that, what should I do? Size minus minus, right? And then before that, I'll put this early on. Also, if L size equals to 0, then I shouldn't pop, right? Return -1 or something like this. If, and let's say this is only right, then I'll have to put this here and then return data here. And then what should I do is free dnode, and this will delete it, right? Now should I do it? This should work. Let me check if I made any mistakes. Make clean, make main. It didn't insert it properly. Oh, I used this too early to begin with. My bad. I have to put it here, right? Make clean, make main. Yeah, so 10 is printing correctly, right? Let's check if this works after I do this. Make clean, make main. So how did this work is that, so I'll do only this. Insert head. make clean, make main. And this will only print out 11, obviously, because this one is the first one that puts in, and then it pops, and then I print out the last element it printed. So this works pretty well, right? Let me check if this works well. Clean, make, main. Right, as you see, 11 is here. Let's check for now. What I will do is trying to make a queue now. Instead of inserting on the head, which is putting on here, now what I will do is I'll put at the tail, at the end. How I'll do it is insert tail int data and list pointer L. And then after that, I'll put this as void stack. Something that looks like this. And then void q. List pointer q. Initialize list. Insert tail, which this is in queue technically speaking. So what would I do? Let's do 1 queue. Insert tail, and then pop will be the same because it's gonna be at the very front, very back, right? Very front, and this will be inserting at the tail. How should I do this? Is that this should be same. It's pretty similar pattern with inserting on the head. So I'll just use this because it takes a lot of time. And then the things I need to change is that this part is equal, but what now it changes that instead of new node being nest, the L tail next should be new node, right? Then L tail next, this part next will be in the new node. You linked it here, and then you have to update the tail, right? So how should I update it? Simple. Put it like this. And then I think this should do it. Then let's call it Q. So make clean, make main. One is printing correctly, right? And then let's try this. 2. Now this should print out 2, right? Okay, this is wrong. Pop. L tail next is new node. New node equals to data, and then I'd update this. Yeah, because it's first in first serve, right? Yeah, yeah. I was right, but I was confused for a while. So yeah, this is right. So this one should be pushed first. So this one is the first one that should be printed. Let me try to introduce. Now I'll make void single linked list. What should I do? List pointer L is initialized like this. And then how I'll do is insert head 10L and then insert tail to L like this. And then I'll just do this. Why do I do this twice? This should be L. Make clean, make. Oh, my bad, I forgot to call this. Make clean, make, main. Yeah, so it's, and how would I make a function that prints everything that's inside of data structure? Void print list pointer L. While, how should I do it? So I said node pointer current equals to L dot head. And then current dot next is not equal to null. Current equals to current next, right? Then what should I do? Printf d and then current data, right? This will do it. And then instead of using stuff like this, I can just put this one, right? Let's see if this is working. No, it was wrong. Okay, interesting. So 10, 2 was printed, and then I printed L. Now I set this one to be head, and then after that, the current next to the next part. Oh, there's an error. So this printed correctly, but the current next, while I was inserting on the tail part, this part was not able to know that the head next is this this one. I think there's nothing wrong with this one, but let me book it like this way. This should work. Make clean, make main. Let's try more. 3. Make clean, make main. So the first part is not being printed, and the reason is because, oh, I put this as this next one is not equal to null. So so the head part is being printed correctly, but it didn't grow 10 here, right? Why did this happen? It's probably because the insert head part is wrong. Um, no, I should have put it here. Current. My bad. Oh, it's not saved. Make clean, make main. Do it to 10, and then after that, now it's printing correctly. So let's check if this is working. Tail. Make clean, make main. Yeah, so it's printing correctly, right? This is at the tail. And yeah, this one came in first, and then it stacked on the two on the front part, and then the tail part is at the this. So this is the how the stack and queue work, and then for the more single list part, I'll do it in the next lecture. Thank you.